Hi everyone, welcome to our first surface area video. We're going to talk about what it is and how to find it. Today we're going to be talking about prisms. We're going to do a rectangular prism, a triangular prism, and a hexagonal prism. So here is your list of formulas, and these are just our basic formulas. These are great to write down, and if they're not on here, if there's a shape we're going to find that's not on here, we can absolutely use these formulas to get the surface area. So you can screenshot this, you can pause the video and copy this down, but these are great for your studying purposes. So again, we're working with mostly this top formula today. Okay, so using that formula, we are going to work on a surface area of 3 different objects, but let's talk about the idea of surface area first, since this is our first video. Okay, so surface area is what we're going to find most often. You'll also see we're talking about lateral area. But surface area in general is the area of the outermost part of an object. In other words, and what you'll hear from a lot of teachers is it's what can you paint, right? So it's that outer layer, it's the outer surface, and it's two-dimensional. We're finding the area of it, so not volume. The lateral area is part of that surface area. So this value in purple is always a portion of this area right here. The area of the surface that is not the bases is the lateral area. So some teachers may have you find it, some may not, but it is important to be able to find it. Okay, so in this object, we'll talk about these two values. The first is the lateral area. So if we want the lateral area, it's everything that's not the base. This is a triangular prism. That means the triangles are the bases. So I'm actually going to color, because this is going to be our base color today. So we've got our 2 triangles, those are our bases. So then everything else is the lateral area. So in purple is the lateral area. So if I were working on this problem and I wanted the surface area of the entire object, I would find the area of these 2 bases, and then I would find the lateral area and I would add those together. Okay, the reason we always go from a 3D object to a 2D object like this is because we like to see what's called the net. The net shows us two-dimensional what this object looks like. So let's start with the first problem and we'll talk about what it looks like as a net. So we've got a rectangular prism first, right? Here's the dimensions. And let's talk about this as a net. So I've got right here a net of a rectangular prism. I'll zoom out just a little so you can see it. Okay, so flat, this is what a rectangular prism looks like, okay? If we were to make it 3D again, we would have to fold it up, right? And then we would have our rectangular prism. Okay, I'm moving around so you guys can see what that is. Okay, so you'll notice I've already got the bases labeled. So I've got the bottom base, and then if you flip it around, I've got the top base. So those are the bases. That means everything else, so everything that's white with no B is the lateral area. Every object has a base or 2 bases, and then the lateral area, which is everything else. Okay? So if we were to open this up, these 2 right here would be the bases that my fingers are going on. Everything else is the lateral area. Okay, so now that we've seen that with an example as a net, let's try it with this problem right here. So the first thing we need to know is what are the bases? Well, looking at this object, it's definitely a rectangular prism. So I'm really just going to pick one side, and then the side opposite it is going to be the 2 bases. We're doing our bases in this dark yellow color. So I'm going to make this top rectangle one base, and then the bottom one the other base. So now I know those are the 2 bases. I'm going to start my surface area by finding the area of those 2 sides of this object. So we've got our base, we've got 2 bases, right? And let's find the value of that below. Okay, so we've got 2 times, and then our bases are rectangles, so that means we're using length times width. So length times width. So underneath it, I'm going to write what those 2 values are. Well, the length is 9, and the width is 5. So when I find that value, 9 times 5, that's 40, 45, and then times 2. Okay, so we've got 9 times 5 times 2, and our total is 90. Now that's not the surface area. We've only found the two bases so far. But if we were painting this object, so everything around it, I still need all of these other sides for the total surface area. So let's find the lateral area now. That's the area that's everything else, everything that's not the two bases. So we always say LA for lateral area. And that's all of this right here on the sides. Okay, so the lateral area, and if we use our formula from before, it's the perimeter of the base and then times the height of the prism. So basically what we're doing is, and let me write, this is the base right here. So remember, these are the two bases. Now, if I want to have what the area is all around it, so we're going to close this up. Remember, I've got my two bases. I'm trying to find these sides right here, all of these. Now, if I were to unfold them and make them one shape, the perimeter of my base would be the length of that rectangle, and the height would be the width. Okay? I'll show it in a little bit better of an example later, but just trust me on this. It's the perimeter of the base times the height of the object. So the perimeter of the base plus, so base plus the height of the object, okay? So below, the perimeter is going to be 5 plus 9 plus 5 plus 9. So 5 plus 9 times, it should be times. And then the height of the object, well, the object is 6 yards tall, so 6. Okay, let's find out what this value is. So 5 plus 9 plus 5 plus 9, that's 28 times 6. And that gives us 168. All right, so we have the two bases have an area of 90 total. The lateral area, so all around in purple, is 168. And then our last step is to add these. So I've got 90 plus 168. And that gives us 258. And then don't forget your units. We've got yards. And this is not volume, so we are squaring our units. It's area, it's 2D, so 2 as our exponent. Okay, so that's our rectangular prism. Let's move on to our triangular prism, so kind of like our very first example I showed you guys above. All right, so this one we've got this net right here, and it'll be a little different than the picture, but the same idea. So we've got our two bases are the triangles, and then if we were to fold this up, we have a triangular prism, right? Triangular prism. Now this one's a little easier to see why the lateral area has the dimensions that it does. So I'm going to kind of shade real quickly the lateral area in purple. So it's these three rectangles right here. Now when we find lateral area, you could just find the area of each one of these rectangles and add it together. That's totally fine. But our formula tells us that the dimensions of this rectangle, this entire rectangle right here, is the perimeter of the base. So you'll see these edges all line up with the base. So I'll kind of try to show you right here. See how those edges all go around the base? So when we open that up, this length right here is just the perimeter of that triangle, okay? And then the width of this rectangle, so we've got the length, and then the width is just the height of the object. So remember, if we fold this up again, remember, this height becomes the side of that rectangle. So that's where those values come from. That's where that formula comes from. Okay, so now that I've kind of explained a little more, we're going to jump into using our formula, but for a triangular prism. Okay, so let's start with, again, our two bases. It's these triangles right here, so I'm going to just outline them. So we've got the one on the top and the one on bottom. Okay, so we've got two bases. And then we know we're going to add the lateral area. So we're going to put that off to the side. We'll do that in a moment. Okay, the two bases are triangles. So we've got 2 times 1/2 base times height. Remember, this is a triangle, and then we have two of them. Okay, let's input these values now. So we've got 1/2. The base of this triangle is 10. And the height of the triangle, careful, it's this 4.5 right here. So 4.5. Okay? And now we need to find this value. This 2 and this 1/2 are going to cancel. So we've just got 10 times 4.5. So 10 times 4.5 is 45. And we're done with our two bases. So we've got part of the surface area so far. Let's try the lateral area now. So we're going to take the perimeter of the base and we're going to multiply it by the height of the prisms or the object, whatever you want to say. Okay. The perimeter of the base, let's find that. So we've got 10 by 5 by 9. So we're going to add those together, 10 plus 5 plus 9. And then the height of the prism is this 6 right here. Okay? So in my calculator, I've got 10 plus 5 plus 9 is 24. And then we multiply it by 6. So my two values I'm adding are 45 plus 144. Okay, let's find the total surface area. We should get 189, and then our units are inches squared because it's surface area. Okay, last object, we'll do a little harder one. It is a hexagonal prism. I don't have a net for this one, but this same exact formula works just fine. So we're going to find the two bases and we're going to add the lateral area. So let's start with the two bases. It's these hexagons right here. And then we've got the one on the bottom. Okay. So we've got two bases. And just like before, we'll add our lateral area later. Okay. So the two bases, we're going to find the area of two hexagons. We've done this before in our volume video. Same idea is going to work here. So before I do this multiplication right here, I'm going to kind of just draw one hexagon and show you how we find the area. Okay, so you'll see drawn right here is from the center of the hexagon and then perpendicular to one of these sides, and that's 9.5. And then it tells us that all of the sides are the same, so all of these are 11. So I know this is also 11 right here. If that's true, well, I can think of this as being broken up into 6 triangles, right? So I'm going to make this a triangle right here and then kind of highlight this so you can see. So just one triangle, and if we were to make 6 total, it would make up the entire hexagon. Okay, so if we find the area of one triangle, we can multiply it by 6 to get the whole thing. So this triangle right here is 1/2 base of 11 and height of 9.5. So let's find what that area is. So 0.5 times 11 times 9.5. So this gives me 52.25. And then we need the whole hexagon, so we need to multiply this by 6. All right. That gives me 313.5. This is the hexagon area. So that's just one base. Okay, so now that we have that value over here where it says two bases, let me zoom out just a little bit. We're going to write 2 and then the area that we just found of one base, just like that. Okay, don't forget we're going to add our lateral area. Our lateral area is the perimeter of this hexagon times the height of the object. So the perimeter is, well, there's 6 sides and each one is 11, and then times the height, which is 5 right here. Okay, let's find these two values. So let's find this one first. It's going to be 627 plus, and then over here we have 330. Last step is to add them all together because we want the total surface area. So plus 627, that gives me 957 yards squared. So now you've seen 3 different prisms and how to find the surface area. Stay tuned for my next one, and we'll move on to pyramids, cones, and cylinders.